Yeah, you're welcome to today's class. Mr. Joshua by name. And today we are going to be looking at trigonometry ratio, introduction to trigonometry ratio. We are going to be explaining the fundamentals of trigonometry ratio. We are going to be looking at the introductory aspects of trigonometry ratios. So very common, one way or the other, we must have been hearing about SOH-CAH-TOA. And sometimes we don't know the basics to how all of this works. So let's start our class first of all by having our diagram. Let's have a diagram to represent what we are going to be using to explain. Let's say this is our right angle triangle, and here we have our 90-degree, so our perpendicular. We have our given angle here to be what? Theta. And then we have our angle here to be what? 90 degree. 90 degree minus what? Theta. So let's move on. Basically, first of all, we need to know that for us to know where our adjacent side is, because there are three sides in a right angle triangle. We have the opposite, we have the adjacent, and we have the hypotenuse. So it is very important for us to know which side is adjacent, which side is opposite, and which side is what? Hypotenuse. But basically, the first side to look out for in a right angle triangle is the adjacent. And then how do we locate the adjacent? Very simple. The first thing to identify where our adjacent is going to be is that wherever we have our given angle, there are two conditions to that: our given angle and our what? Perpendicular. So this is the first condition and this is the second condition. So you must ensure to know that you have your perpendicular and you have your what? Given angle. Now, if you look at this, you will realize that they are lapping and resting on this side of the shape. They're on the same line. That is here. They're on the same line. That makes that side the adjacent side of the right angle triangle. Now, basically, here we combined two different shapes together so that we can explain a concept. So if we are to separate this shape, we are going to have this. We are going to be having the first shape to look like this, and then we are going to have the second shape to look like this. This will be 90 degree minus what? Theta. So we combined these very two shapes together to form this so that we can just use simply a shape to explain the two concepts at a go. So meaning in the previous diagram that we have two given angles there. But let's consider the first given angle theta and the perpendicular, which is going to be this and this. So for the first aspect, we are going to be dealing with theta as our angle, as our given angle. So in that bit, that makes, since our theta is our given angle, which we are considering here, that makes this place our what? Adjacent, our hypotenuse, and then our what? Opposite. Now, the hypotenuse side is the longest side of the right angled triangle. And then another thing is our given angle most times faces our what? Is opposite to our, is faces our opposite side of the shape. If you look at this angle is facing this direction. So that is another way you can use to identify your opposite. The angle faces that side directly. Irrespective, not to confuse you, you can just come to a conclusion anytime you want to know which of the side is opposite, hypotenuse, or adjacent. The first thing is look out for the adjacent side. And like I explained initially, your adjacent side is going to be wherever you have your what? Your giving angle and your what? Your perpendicular, which is your 90 degrees. So having stated that, you should be able to locate where your adjacent, where your opposite, and your hypotenuse is. So to practice that, let's say I have a diagram like this. Can you try that on your own? Let's say our given angle is beta. So try to solve this question and find your what? Your adjacent. Find your adjacent. Don't forget, there are two things you need. Number one is your what? Your given angle. And then number two is your what? Your perpendicular. Perpendicular. These are the two conditions. So wherever any of these, whatever line any of these rests on, is going to be your what? Your adjacent side. I hope that is clear to us. Okay, in that bit, I think we can move on from here to explaining what we needed to explain so far. So we are going to be explaining the fundamentals of the basic trigonometry ratios that we have. They are about three. There are about three basic trigonometry ratio that we have. And what are those trigonometry ratio? Very common. We have our sine, we have our cos, or let's use it fully, cosine, and we have our what? Our tangent. Our tangent. Okay. So our sine is what we refer to most times as our SOH, then our cosine, CAH, and then our tangent as TOA. Okay, so we represent, what is the meaning of this? So this means our sine theta, because we are dealing with this given angle here. Yes, because we are dealing with this given angle here. So our sine theta, which is our given angle, you work with your given angle, will be equals to what? Opposite over what? Hypotenuse. So the S sign stands for sine, the O stands for opposite, and the H stands for what? Hypotenuse. And then moving on to the next, we have our cos. That is the short form of cosine. Cos theta, because we are dealing with theta here, is going to be what? Adjacent, A for adjacent, and H for hypotenuse. You can see this is very simple. And then moving on to the last, we have tan theta equals what? Opposites over what? Adjacent. Over adjacent. Yes, that is going to be the three basic trigonometry ratios that we have. So when you know this is what all other trigonometry ratio builds upon. So having known that, let's now figure out how to identify what we are going to have for our opposites, our hypotenuse, and our adjacent. So in this bit, permit me to draw a new diagram so that we can use that to explain all of this very explicitly. So let me draw a new diagram right here. to showcase that. So let's say we have this diagram repeated again, and then we have theta. Permit me from a diagram, and then we have 90 degree minus what? Theta. So what is the next thing? Let's label the sides of these triangles as A, B, and what? And C. Okay, having that, let's label each of the sides, the opposite sides of the angle. So that means we have angle A, which is 90 degree minus theta. We have angle B, which is 90 degree, our perpendicular. And we have angle C, which is our what? Our theta. So let's label the opposite sides of each of these angles the small letter of whatever letter we've used to represent the angles. So here, that means starting from the side, this is going to be small letter C. Let me make it a little bold. Small letter C, and then here we have small letter B, and then we have, let me do that again, small letter B, and then we have small letter A. Can you see that? You can see this is facing this is facing this, and sorry, this C is facing here, and B is facing here. So that is how we arrived at naming the sides. You would notice that capital C is facing small c, your capital B facing small b, capital E facing small a. So in that bit, let's apply our SOH-CAH-TOA in ensuring that we are able to understand this well. So that means having to deal with our theta as our given angle. Don't forget, we are also going to solve for 90 degree minus theta as our given angle. But for the first part of this, we are going to use what? We are going to be using theta as our given angle. So here we're going to have sine theta equals, what is our opposite? Now, I told you that for us to know our opposite, first of all, we have to figure out where is our adjacent. We all know that our hypotenuse, since we have our given angle to be theta, now we have to ensure that we are dealing with theta as our what? Given angle. Let me mark that. So this has to be our given angle and then our what? Perpendicular. So that means where these two symbols are resting upon is our what? Our adjacent. Like I explained earlier, the longest side of this shape is going to be what? Our hypotenuse. And then the other part is going to be our what? Our opposite. Okay. All right. So moving on, let's go on to our trigonometry ratio. So sine theta is opposite over what? Over hypotenuse. So what do we have as our opposite? What letter do we have there? We have small letter C over what? Small letter B. Our B is our what? Hypotenuse. Then we have cos theta, which is adjacent over what? Hypotenuse. What do we have as our adjacent? We have small letter A over what? Small letter what? B, which is our hypotenuse. Then the last one, we have tan theta equals opposite over adjacent, which is what? Our opposite is small letter C over our adjacent, which is small letter A. So we've been able to use this particular shape to determine our cos theta, which is carrying this value, and then this as well. Okay, so feel free to try that on your own. Feel free to try that on your own. And then the last part of the class for today is that we are going to do the same sine, cos, and tan theta and tan for our other given angle, which is our 90-degree minus theta. So this time around, instead of using theta, we are not going to be using theta for a given angle. We are going to be using 90-degree minus theta as our given angle. So what does that mean? Not to confuse you, you can either use the same diagram if you can, but if not, you can draw a new diagram like this, as you can see it on the screen. So you're gonna have theta, you're gonna have theta, the perpendicular, and then the last given angle, which is what, 90-degree minus what, theta, minus theta. Just permit me. I believe you understand what I'm trying to figure out there, okay? Let me make it a little bit clearer. This is 90-degree minus what, theta. Okay, good. So we are going to be working with this. We're going to be working with this, not to confuse us. So still repeating the same trigonometry ratio. So we're going to be having sine theta. We're going to be having cos theta. Sorry, not theta any longer. It is going to be what? Our given angle is going to be 90-degree. Let's not forget that, minus theta. Then we're going to be having cos what now? Let's put this into bracket to make it more organized. Cos, open bracket, 90-degree minus what? Theta. And then the last one, which is going to be tan 90-degree minus what? Theta. Okay, so in this bit, what are we going to do next? The next thing we're going to do is that let's see how we can move on with this. So the first thing we're going to look out for is that we have to locate our what? Our adjacent side this time around. Now, you have to be very careful and understand that you are no longer dealing with what? Theta any longer. So this is out of the equation. So what you are dealing with in the actual sense is what, 90-degree minus what, theta, as your given angle. Don't forget, wherever you find your given angle and your perpendicular is going to be your what, adjacent side. That is where the shape is resting on. So in that bit, we have our 90-degree minus theta appearing there, and we have our perpendicular appearing here, which tells us that our adjacent side, where the shape is resting on, is going to be here. So to make it a little bit clean, so what do we do? So let's label here our adjacent side, our hypotenuse, which is the longest side, and definitely this is going to be our opposite. If you know you can be confused, you can simply turn your screen to ensure that you are seeing your 90-degree minus theta and your perpendicular on the same line. So we are still working by the same way it was being labeled in our first diagram. So that means here still remains our small letter b coming. Here remains our small letter b. Here remains our small, let me use a red. Okay, here remains our small letter b. Here remains our small letter c. Here remains our small letter what? E. Our small letter A, our capital A, capital, let me use, okay, no, sorry about that. Let me use A for here, B, and then C. So it's not hard, very simple. So moving on, let's now apply our trigonometry ratio. So sine 90-degree minus theta is going to be opposite over hypotenuse. Don't forget, our adjacent side has changed because we are dealing with 90-degree minus what, theta. So let's figure out where is our opposite. Our opposite is A here. So that means our opposite is going to be A over our hypotenuse, which is what, small letter b. So that means our our hypotenuse is going to be what? Small letter b. Moving on, we're going to have cos theta, which is what? Adjacent over hypotenuse. Our adjacent is what? Small letter c over hypotenuse, small letter b. And then the last part, which is tan 90 degree minus theta, which is opposite over adjacent. Our opposite is what? Small letter a. And our adjacent is what? Small letter c. So in this bit, we've been able to lay down the foundation of this. So we have this, we have this, and then we have this. So there are about 6 different trigonometry ratio. You would notice something around here. You would realize that the value of the 2 trigonometry ratios, even though same sign, but then the theta is different, you'd realize that their values are different. Sin theta says small letter c over small letter b. Sin 90 degree minus theta says small letter a over small letter b. So having known this, we are going to be using this to prove some questions in our next class. Don't forget to like, comment, share, and make sure you subscribe. Thank you very much. I am Mr. Joshua.